Quadratic functions of the form f of x equals ax squared plus bx plus c. The graph of a quadratic function is called a parabola. A quadratic function in standard form, which is f of x equals ax squared plus bx plus c, opens either up or down depending on the value of a. If a is greater than 0, then the parabola opens up. If a is less than 0, then the parabola opens down. The point on the parabola where you turn around and change direction is called the vertex. Depending on whether the parabola opens up or down, the vertex will always contain either the minimum or maximum value for the quadratic function. If a is greater than 0, we said that the parabola would then open up, and that would make the vertex the minimum point on the graph of the quadratic function. If a is less than 0, then the parabola opens down, and it makes our vertex the maximum value on the point of the quadratic function. A parabola is symmetric with respect to the vertical line that passes through the vertex, which is called the axis of symmetry. For any quadratic function written in standard form, f of x equals ax squared plus bx plus c, the axis of symmetry can be found using the formula x equals negative b over 2a. Since the axis of symmetry passes through the vertex, this is also the x-coordinate of the vertex. The vertex is a point on the graph of the quadratic function. Being able to locate that point is essential to most application problems that involve quadratic functions, since this point represents the maximum or minimum value of the function. If we already know that the x-coordinate of the vertex can be found using the formula x equals negative b over 2a, we can find the y-coordinate by plugging this x value back into the quadratic function, thus calculating f of negative b over 2a. For our first example, we want to find the axis of symmetry, the vertex, identify the vertex as being either the maximum or the minimum, and sketch a graph of the quadratic function f of x equals negative 2x squared plus 8x minus 3. We start off with the axis of symmetry. We know we can find the axis of symmetry using the formula x equals negative b over 2a. Well, in the function that we were given, the value of b is 8, and the value of a is negative 2. So we get the negative of 8 divided by 2 times negative 2, which we work out to be a value of 2. Now, the axis of symmetry is a line, so when we write the equation of that line, we must write it as x equals 2. Once we know that value, we can figure out the vertex. We know that the vertex has an x-coordinate that's exactly the same as our axis of symmetry. So we know that the vertex is the point 2, and then the y-coordinate that goes with it will just be the functional value at 2. So the functional value at 2 means to plug in 2 to our quadratic function. So everywhere we have an x in the original, we are going to replace it with a 2, and we'll get negative 2 times 2 squared plus 8 times 2 minus 3. And when we work that out, we get a y-coordinate of 5. So our vertex on this parabola is 2, 5. Since our a value was negative 2, which is less than 0, this parabola will open down, which makes our vertex 2, 5 a maximum. To make a quick sketch of this graph, all we have to do is plot the point 2, 5 on the xy plane and draw a parabola that opens down. An application problem, an ice cream vendor uses the function f of x equals negative 35 thousandths x squared plus 6.3x minus 247.5 to help estimate his daily ice cream sales f of x based on the forecasted high temperature of the day x. What forecasted high temperature will yield him a maximum amount of ice cream sales? And we want to round this number to the nearest whole degree if necessary. And then what are the maximum number of ice cream sales? And again, we want to round this to the nearest whole number if necessary. Since this model is a quadratic function, we look back at our f of x. It is in the form ax squared plus bx plus c. We know that the maximum will occur at the vertex. We know that the x-coordinate for the vertex, which is what we're being asked for in part A, which is the forecasted high temperature, can be found the same way we find our axis of symmetry, using the formula x equals negative b over 2a. The value for b in this function is 6.3, and the value for a is negative 35 thousandths, so we can plug them into the formula and simplify, and we get an x value and a temperature of 90 degrees. For the maximum number of ice cream sales, which we are told is f of x in the directions, all we have to do is take our 90-degree forecasted high and plug it into the function. The function tells us ice cream sales when we know temperature. So we're going to plug in 90 everywhere we see x and simplify, and we determine that the maximum number of ice cream cones he will sell in one day is 36, and we know that that occurs on any day where the forecasted high is 90 degrees.